Hello everyone! Finally, I finished this update. This took me way too long, but here you can see our new assistant, the tour manager of the new update. I'm gonna go through the new things that changed. Actually, it changed so much. There's so many new things in the update. I completely rewritten it. It's no longer blueprint based. In the Unreal Engine side of things is now a C++ code only plugin. And in terms of TouchDesigner, I'll show you that it also changed quite a lot. So it was a really nice process, maybe a bit too long for my own sanity, but it was great. So I'll show you a bit around what new things are in store and what you can expect from this tool. OSCToolset is a plugin for both TouchDesigner and Unreal Engine. And if you're a TouchDesigner user, you can think of it as TD Ableton. It is a plugin that uses OSC as its communication protocol, and it's a two-way communication system between both Unreal Engine to TouchDesigner and TouchDesigner to Unreal Engine. What I managed for this new update is to send data from Unreal to TouchDesigner for sending events or floats, and mostly it started as a way to send information from TouchDesigner to Unreal Engine. So that's where most of the modules are. So for example, you can send events, you can send locations, you can send rotations, colors, and transforms. At the moment, this plugin is focused on channel data. So that means that we are mostly using chop data from TouchDesigner in order to send it to Unreal. But this new update, I also added a little bit of strings, so you can also send text. It's very basic and it's not the main focus of the plugin at the moment, but it's something that it's useful as well for certain things. The plugin works for TouchDesigner non-commercial licenses and commercial licenses, of course. And it will depend if you're going to make money or not with this, that you will have to check what each software requires. And for Unreal Engine, it works for all the versions that are available at the moment. Before going through the examples of this new update, I wanted to show a very simple example of having a sphere move a little bit in Unreal Engine. And how can we send data from TouchDesigner to Unreal? When you purchase this plugin, there will be these two folders. This is for the examples, and this is the base plugin. So this is what we want if we start from scratch. So here for the TouchDesigner, there is this folder called TouchDesigner. It contains the talks. The talks is the component. So all you have to do is to drop it into a new project, and that's all you need to do for TouchDesigner. For Unreal, if you go back one, you will see that there is a folder full of versions. Depending on your Unreal Engine version, you just choose it and copy this to the plugins folder. I will go more in depth how to do that because it relates to the packaging of the plugin itself. So here I have an example where I already did it, and how you enable it is that once you have it copied into the folder, you will enable it here, restart the project, and that's it. That's all you have to do. I will show it more in depth a bit later. What do we need? We need a float to send the size, and I want also a vector to change the location. Here in TouchDesigner, I'm gonna make active the OSC toolset, and it becomes like a menu. So here you can select one, and I will drag and drop outside in the network. And I will do the same for the vector tree. So now I have these two modules where I can send data directly from TouchDesigner to Unreal. And now I have to send some channels. So the first thing I'm gonna do is to make some channels. So I'm gonna create a noise. And the noise by default is a sample. OSCToolset is not supporting samples, so you will need to have it as a channel. So you can time slice the noise and you get a channel value. Also going to change the offset to make it 1, so it goes into the positive. Then in order to connect this to the module, you just have to drop it on top and then you select it as chop. You will see that now it's referenced by name, so you could also just type it if you also like that. So you can always say noise 1. And you will see that it becomes active. Here in this preview, you will have a simple preview of the address, which we have to call, and the channel and the operator name. For example, what I could do is to change the channel name to size. So I know that this will be my size. It will also update the preview. Now I'm going to copy paste this noise, and I'm going to make one with 3 channels. I'm going to say X, Y, and Z for the position. It could be named anything. It doesn't require to be like that. And I will show like this. If I will add this as a chop, you will see this one is not yet activated. What you need to add is an address. Here I'm going to say position. So here you will see that the key XYZ is a channel XYZ, but as I mentioned, it doesn't need to be like that. It could be, well, like this, 0 to 10, for example. Here I'm going to make 10 channels, and what this tool is going to do, when we send a single vector, it's going to take the first 3 channels. Here you will see the name of the channels and the address. I will go a bit later how this works in the debug view, but for now in TouchDesigner we are done. Now for Unreal, what we need to do is an actor. I'm going to make a new blueprint. I'm going to create an actor, and I'm going to call it BP Sphere. Inside this blueprint and inside this actor, I'm going to add a sphere component. And then this is where we're going to call the modules. Modules in Unreal Engine are components. They are actor components. So here I can add a new one and say get float. And this didn't change that much from the last update, but there's a few new parameters. For example, we have to specify the operator name. And I did this because sometimes the names of the channels would collide with other modules, and that was really annoying. This makes sure that we are using the operator that we want plus the name. For the float, if I zoom in, you will see that the chop, so the op name is noise1, so I can type it here. You can also see it here, noise1. And the address I need is size. And then I need to add the vector3. So here I'm going to say get vector3. And I will do the same. So I'll just go here and I see operator name is noise2 and the address is position. Now I'm going to compile. I'm going to save. How do we get the data? We get the data by using event dispatchers, and they can be found here. These are going to be triggered every time that we get a message. For example, if I select the vector3 and I say get vector3, this event is going to trigger every time this channel is changing. What I want to do is to, for example, get a sphere, and I'm going to say set the location, relative location, like this, and I'm going to connect it. Now we are going to set the location with the value that we're getting from the first 3 channels of this chop, and I'll do the same for the float. I'm going to get the float, I'm going to get the sphere, I'm going to set the scale, and the relative world scale. That's also fine. Connect it. The reason I'm using a float for the scale, it's because I want it uniform, but you could as well just connect another vector3 or whatever you want. Now once this is saved, the only thing we have to do is to add it into the world. And if I play, you will see that my sphere is changing scale, but it's not really moving. And the reason is that the designer's noise is very small, so you can see it goes from 0 to 1, and then it does move, but it's so small that you don't really see it. If I stop size, if I go a bit close, you will see it, it's a little bit moving. What I can do, I will select the noise for the location, and I'm just going to change it. I'm going to put it at 100. And this is what I like a lot from this plugin, is that it allows us to just play with both programs like really quick, and it directly and automatically connects everything, which is really nice. And this is how you would do it. This is very rough approach. There's a lot more things to go through, but that's why I created a map full of examples that I made a puppet for. So let's jump into it. Then back to the examples. The same way that you will get the folder with the base plugin, you will get a folder with the base examples. These are very basic, just as they act as documentation mainly. Here you will have these OSCToolset version 2 examples, and you have, again, 2 folders. One contains a TOW file for the examples of the designer, and the other contains the project with the plugin installed. So you can just open both. And now we wait a little bit, because it takes time. You gotta be patient in life, you know. Sometimes. Okay. I've been really patient with this plugin, honestly. I work so much. It's fine. See, Unreal is always a bit slower. It's what it is. There you go. So I have it open. And this is how it looks. So if I play in Unreal, you will see that this guy is here. And if you see these things moving, it means that it went well. If it's not moving, then you should send me an email. But hopefully you don't have to. How is it structured? Let's take a look. I made color-coded examples so you can easily see what is what. For example, the same colors that I'm using for events, floats, etc. is the same colors that I'm using for the examples. So here, if you see this OSCT event, I'm sharing this like reddish example, the same for the sender, and the floats just go like this. What I recommend is to make the projects side by side like I have at the moment and just go through it like this, and that will kind of help. As well, I made sort of explanation, so when you enter a specific example, you will get this type of explanations. I will go through it a little bit now, but it's always nice to have if you just don't want to listen to me too much and you just want to read a little bit. Here, this didn't change. This is the example of the tick rate. This is here. If I stop, you will see that this disappears. What this is showing is we don't have to send messages at the same rate that we are displaying them. It's important to understand that Unreal Engine and TouchDesigner are two different programs, and they run in their own separate threads. And we send OSC in a way that we might not need to send it to a really high rate. And this is because Unreal already has its own frames per second. So if I here add the FPS, you will see it's running at 60. And this can be controlled through TouchDesigner by this. So you will see that the red box is using the rate of TouchDesigner, and the green one is using the smoothed version of Unreal. It's now like flickering because the debug probably that I'm using, it has a very short drawing rate. Otherwise it was leaving trails, so just leave that at 30. But it shows how we can smooth out an input message without the need of sending this OSC message at 60 frames, right? Because if you will see, I put it at 60. It's not that different, and we don't even need it. We already cut by half the performance of our projects, which is great. At the moment, I'm recording at 2K. This is like a 2060 NVIDIA graphic card, so it works really well in that sense. It's quite performant. Let's take a look into the TouchDesigner side of things. We have senders and we have receivers, and the senders will be in this side. We have normal single senders, we have pack senders, and these will be the receivers. So let's take a look at events. Events didn't change that much, so it's a bit similar. When you select an event, you will see that they are selected in red. So basically, if I stop and I select this sphere and I press Ctrl-V to navigate at the location, if I open it, we will see that there is a module in this blueprint called getEvent. And I'm targeting the beat event, so it's probably this chop. And the name of the channel is ramp1. This is up to you. So for example, you could say, I want the channel ramp4. And this you can save. And if you play, you will see that now ramp4 is connected. And I'm using that specific channel to target the event. Now, I'm also going to change something here because I kind of don't like it. If you tick these dots, you can say you want to start at the camera location. So that will make it so that you don't have to go through the whole thing all the time. So then we have the float, really simple as well. Floats and events are something I call single channels. And the reason is that the address at which we are calling is the name of the channel. For example, channel 0, as you can see here, is the one that's being selected. We don't have to set addresses for either floats or events. So when you select these ones, you will see that they are not selected. But we do have the need to add an address for data that has more than one component. For example, a vector2 has an X and Y component, or a transform has like 9 components. So then we need to add an address that represents that pack of components. That is why we have a single channel and a multi-channel difference. You will have here the representation of what address you need to call. So for example, this has X and Y keys, gives you the channels, and it will give you the address. So you can always come back to TouchDesigner and see what you need to send. As we are in this vector2, what it is, honestly, it's just like X and Y. You don't have to use it for location. This could be for anything, but it's just to show a little bit how you can use these data types. For example, we have a vector3 to send locations, which is kind of useful. and a rotation. So here I'm going a bit fast, but this is the rotation, for example. And you can always go to this node, which is the one triggering the rotation. And you will see that the moment I stop it or I bypass the operator, the rotation stops being sent. And you can, of course, change here the amplitude. I could add a 300 and it will go a lot more crazy. Or you can increase the period, so it's a lot slower. And what I like from it is super responsive, which is I'm really happy with, because we don't have to wait for a lot of things. It's just like, if I don't want it, I take it out. If I like it, I bring it back. That's pretty great. Then rotation is a new module, kind of useful as well. Color as well, same as it was. We could send and convert colors from TouchDesigner to a channel. We still use the same system. For example, this is quite a big channel count because we have 20 colors, and the single one will take the first 4, right? So it's taking R0, G0, B0, and A0. So these are the first 4. If we would rename them or reorder them, it would just take the first 4 in index order. Just consider that if you work with this. And we have the transform, which is going here quite nice. As you can see, here are the packs. I will go to this later. And that's it for the singles. Then the strings are also packs. Let's go all the way to the front to check the packs, how it's going. How can we get packs then in Unreal Engine? What you can do, I'm going to stop this. Here you will have the folder with all the different data types. So for example, I will go to event, and we have the event, which would be the single one. It's there, you can see it. And this would be the pack, which would be this one. I'm going to open this, and this is the blueprint that is generating this, right? That's why we're going to take a look how this is created. Inside the blueprint, I'm using 2 events from the module. One is the init OSCT module, and one is the get event pack. This one will call every time a new value is changed, and it will send all the channels, right? In theory, all the events. And it's going to tell us if they are either on or either off. What is happening first in the init? In init, I'm basically creating a size for our instance static mesh. And here it's generating a length from the pack that we have, right? The difference and the reason that I do it in this event and not on BeginPlay is that this is called after BeginPlay. What that means is that our init of the module is called once it's ready. So when the data is ready and we know that we have a pack of a length 24, we can then start to initialize the static mesh. You can take a deeper look into the examples and you can see how it's crafted. So for example, this is inheriting from this blueprint. And here I have this function that is taking a length, so a count, and it's creating an array of transforms, and it's adding an instance to that mesh, right? So this is a blueprint that is inherited for all the types. And depending on the pack size we send from TouchDesigner, we can set a X amount of instances. That's how it initializes. I hope that's not too much for most people. I'm sorry if it is. Otherwise, I can go another day and start this from scratch. But just as a heads up of how it works. Then in the event get pack, we get the pack. Oh my God, this thing is getting out of hand. Please help me. So this event, as I said, triggers every time the channel changes. And we get the event pack. We get it as a map, which is a data type in Unreal. And this data type contains a key and a value. The key in this case would be these addresses. Here in the pack, you can see that they are named RAM1, RAM2, RAM blah, 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 right? The first event, the key will be RAM1. And what I can do then is to iterate over this map, right? Every time that there is a new update, we iterate over the map for each value, and we find the value. Here I get the key, which would be all the subsequent addresses, and I get the map to find the value. The value will give me a Boolean, which will change the scale depending if it's 0 or 1. 1 will be true for the Boolean, so it will make the scale 1. That's why when we play, we see that they appear and disappear. Here we can check that the event is connected. For example, I could change the period, so the speed at which they are sending, or I can make it really slow, or even slower. Let's put it at 16. Now you will see that they slow down on appearance. And you can speed it up as well. That's what I think is great, because you can just make it go quite a lot. Let's leave it as it was. I want to touch that. Then the same thing is for the floats. As I mentioned before, you can go now to float, and there is the example for float pack, and it works the same way. I get the float pack, I get the value of the map, I get the length, and I create the instances. This is just one example of how you could do it. This time, I can make more examples of how to use this tool other than this example file. Please pray to God, everyone. But this is how it works. So this is the same idea. It's just that every different value type has a different map type, right? In the case of the float, it will still have a name of a channel as a key. So for this case would be like channel 0, etc. And the value is now a float. So what we can do with it is to have a smooth transition for the scale. So when I play, I have like this nice transition. The same, let's go now to, let's see, this one. I wanted to go to color, but that's a bit different. So this one, for example, is for the location. So let's take a look. We have a noise that contains 49 channels. When we divide by 3, which is the amount of components that a vector has, we get 16 different locations. These are then sent and fetched by the vector pack. The same way that we just saw, we get the keys and the length, and we set the instances. And then we can iterate over our pack of 16 different 16 different locations. And then we can use the key to find the location, and we can add it and update the instance transform. This is just an example of how you can use these different things. For example, I'm somewhere around here. What happened? There we go. This is a way to get the location, and the same will work for every other single type. The color is the same. The only thing with the color is that, let's be honest, it's just not the way you would send color to Unreal. This is a bit of a patch, right? It's a patch to just, if you want, they need the color, you can just bring it on. But maybe if you would have a bigger project, you would think of sending a texture instead of 1,000 channels for 1,000 colors, right? But it just works, and because it was the same code, I just ended up doing. The example of the color, as I mentioned just a moment ago, is a little bit different because we are using something that is custom instance data. And just to not go too deep on it, but in Unreal, instance meshes that are from a instant mesh component can have custom data per instance, and the material is a little bit different as well. So I just welcome you to take a look and see how it's set up. Basically, we are getting the color and we are setting the different custom data index that needs to be specified previously in the material. Jesus Christ. And and then you can set the color that we send. This example just works, so you can just copy paste it whatever you want as well. No problem for that. So here you get the different colors. And the same I did. I can change and make it blue, for example, or make it go back to this. Now, if I go to the transform, same story. They have different transforms, so let's take a look. We have one for the transform, the translate, the rotate, and the scale. They're all combined together, and then this is all sorted together. And then it's visualized like this. Something I did not mention is that the same way, I'm going to go to the transform pack, the same way that when we get single channels on the module, we also can get the tick. This is also super nice because it means that we can get the pack as a tick event, and we don't have to iterate over hundreds of channels. It's just done in the back for you. You just can drop it here and get it. Remember that you will need to enable the tick, otherwise you can see that if I now play, this will not move and it will be static. Very important. Why is that? Well, I said because it's a matter of performance, and I just want you to be sure you want to enable the tick. Otherwise, don't use it, because if you don't know what you're sending, it can be a bit hardcore. And that's it. Then we have this last one for the senders or the receivers, in this case for Unreal Engine. And this is text. The reason I added this is because it's kind of nice to get text for commands. You can send commands now from here. And let's say I want to add the text, so I can send a message. Let's say, hello, man. So you'll see that it updates. There is like different things that you can basically connect these to whatever. You could make it dynamic, send the strings. What I think is great about the string, as I mentioned, let's take a look. A little different. It's not a pack or a map. It's an actual array because it's already a key. So here you could send a table of arguments for Unreal. What is an argument? It could be a command, console command. For example, we could send the stat FPS, and this can trigger if it's connected or not. You can see that now I get this. If you need to send specific commands to Unreal, this is great. What you can do is to get the string, and when you get the value, you can just say execute console command, and you basically are sending commands from TouchDesigner. Be mindful what you're doing. This can be a bit tricky, just for you to know, but it is now possible, which is really great. That leaves us with the new update. There's so much new things, oh my god. Let's go all the way back to the sender. So what is a sender? Well, I was working quite a lot on this. I did a few projects with it, and one project I was required by my own choice to send data from Unreal to TouchDesigner. And initially this plugin was one way. It sort of was two-way, but you didn't have the option to do anything to send from Unreal to TouchDesigner. But now I enabled it, and I made a few modules where it allows you to send data. What type of data? Let's take a look on the send event. Think that if we are sending from Unreal, it's going to become a receiver in TouchDesigner. The same way that we created the modules, I just get this and I drag and I drop it. That's what you can do. This one is already set up. So I have an address called character interaction, and I have a character enters, character leaves. Maybe you know what's going to happen, but when I enter, I get an event, and when I leave, I get another event. Maybe it's so fast that you didn't see what it happens, because events are considered pulses, at least what I like. Now, for example, you can see that the character enters, character leaves. You have control of a really nice thing in Unreal, where you can just create, for example, this box, and you can say, well, if you enter, send an event to TouchDesigner, and in a way you can create a feedback loop, which I will show you somewhere there. We can also send floats, very simple. For example, this is sphere, and what I'm sending is the distance at which I am. When the character enters, there is a distance value, so you can see that the first one is sending in Unreal Engine units, and it's a distance to the center. When I'm really close to the center, it goes to 0. And then I made a little bit of code to normalize that value. What it means is that when it's all the way out, it's 0. And the closer I get to 1. So you can see that if I jump, it goes a little bit to 1. The message rate at which we receive messages, it's going to be depending on the Unreal project. But we can also filter it the same way that we use tick rate in Unreal. We can use a filter in TouchDesigner. And you can see how much smoother it is after it's filtered. I leave that to you to choose when you want to filter it or not, because the same way that the tick rate in Unreal takes resources, the filter in TouchDesigner takes resources too. So as you can see, this one is cooking all the time, whereas our component doesn't. Here you can just choose if you want to filter data or not, up to you. And then the last thing is that you can also send strings. If you want to send a specific string, in this case, I'm sending the name of the character that is entering, or the name of the class. And if it's leaving, it just sends an empty string. You could choose to do certain things with it, and you can send strings now. And incredible, but that's kind of it. There's a few more things, of course. Why not? For example, I made this place. That's where it started the video. It's sort of a dance hall. Here, if I go all the way here, what does it do? Well, it gets a float, and it says a dance floor, and it has a state. This state is going to control the volume. Once I enter, you should hear the TouchDesigner music, which is actually making me deaf at the moment. And then once I activate it, I'm sending data back to Unreal. This opens the possibilities to make like feedback loops in terms of data, which is really interesting. For example, you can enter here and then in TouchDesigner do something and then you send something back if that's a possibility or not, blah, blah, blah. There's like really cool possibilities that this enables that I didn't thought were possible, but was really fun to actually do. So you can take a look into these examples. And before that, I can show you how the send events work. Same way, we are in the receivers, we go to the senders. Let's take a look at the event, for example. I will open the blueprint. All that it needs is a OSCT send event. For now, we've been working mostly with get, right? So we get data from TouchDesigner in Unreal, but now we want to send from Unreal. Here we get the send event, which is this one. It contains an address. This in this case is character interaction. And then when we create a new sender, so you could also do this, here in the address, you would just add that character interaction. Just going to use the example. The way we add the events that we want to receive, a bit opposite way that we did in Unreal, we need to create them here. Let's say that I want to get the new event, character delay, I'm going to call it, character delay. Now this will be listening for an event called character delay. How can we send that? There is the box, well, this is sphere collision, which takes care that when some component that starts to overlap with it or either ends to overlap, we can send an event. That starts here. On component begin overlap of this sphere collision, we cast to our simple character, which is this weird character I made. We get the component, and then we say send event. And note that is not the class, so it's not the variable, but it is the function. So it's this function called the send event, and that's what we just sent. So how do we send a new event? What I'm going to do very briefly is to add a delay here, and it's going to be called, let's make a delay of like 2 seconds. And then I'm going to send this new event, and the name is going to be character delay. What this is going to do is that when I enter, it's going to trigger the delay a little bit later, as you saw. If I leave, it doesn't work anymore because I don't have the character delay event on leave. I can visualize this again with a trail to check that it's working properly, and gonna directly enter and leave. And you see that the delay triggers after 2 seconds of entering. The same is for the float and the string. It's just that if I get the float, in this here, a float, it sends instead a float, and it's a little different in terms of what we send. We also give it a name. Where is it going to be sent to? In that case, it's called distance, and the distance gets a value. Here I just show an example of how to normalize the value, and we get the n, the normalized distance. That's it. That's for the senders. Really straightforward, but very useful, to be honest. Very useful to get like simple data from Unreal to TouchDesigner. Debugging. Now, this is more the boring part. That's why I will leave it in the end. If you are interested in it, great. Otherwise, also great. It's fine. What is debugging? Debugging will help us to check what data is being sent, what is really going on, and what tools do you have to debug, basically. We have 2 different plugins, so there's like 2 different places to debug. There is the debugging options for Unreal Engine and the debugging options per module. Let's take a look first at the TouchDesigner sketch. I'm going to stop this game so it will be off. How does it work? Well, each module in TouchDesigner will have a debug view, and to be able to read the messages, we need to open the text port. So here I will open the text port, and if I press debug, nothing will happen. The reason is that an OSCToolset only is going to send the OSC messages when there is a connection. I can show when I play, it will start sending the values. So this one is showing us the sending float. So it's the single one, is this one. It's showing us the value that the designer is sending, right? They're sending also, they give you the module that is sending it, the address that is using, and the value. It's kind of nice. We can stop this one, and we can also bypass what it is, like the module itself. These I use for debugging myself. If I am not sure of what's being sent, I can bypass it, and you will see that everything that is being sent is not even filtered. It's just sending everything because we are not getting what channel we want to get from Unreal. be mindful, like bypass is just really to debug in TouchDesigner. It will show this arrow. It's completely not going to send anything to Unreal anymore. And it's mostly for debugging. Debugging is by default turned off because it takes a lot of resources to type and write so much text in viewports and logs and whatever. It will be up to you to enable if you need to debug something. Here I'm going to take it off. If you see something one day on, it will tell you where it is, and you can always toggle it off if it's the case. Now, that's the side of the designer. There is a few other things that I made for debugging purposes. I think I mentioned it a little bit, but just to iterate a bit again on it. When we play in Unreal Engine, we will get this preview of our module. So we get the key at which we are getting, we get the channel name, and we also get address. This float is using the channel 0. That's why it's green. And the rest are red because they are not being used by any Unreal Engine component. I can check here if this really works again. Why not? It's always good to double check stuff. Here in the OSC get float, I'm going to change the channel to, let's say, channel 7, because I see it here on the left. I'm going to save, I'm going to do that. I'm going to play. You will see now that it's being used as the channel that is connected. It's indeed highlighted as green. That means that the channel 7 is the one we are listening in Unreal. This would work as well if I would add new ones. So I'm going to copy paste and I'm going to say channel 6. Now we have like a new module that is being listening to a new channel. So this is one way if you can or need to get specific values, which is also quite nice. So I'm going to delete this because I'm not going to use. But that's a bit how it goes to the TouchDesigner side of things. The last thing is just the package. It has the same thing, but it represents each pack of components that each data type has, right? So this vector tree, XYZ, it will contain this structure. For Unreal Engine, it's a similar approach. When you select a module, you will be able to debug information about it. I tried to the best of my ability to keep debugging colors related to the module color. So when you see like something, you're like, oh, it's green. Ah, okay, it's a float. Hopefully that kind of helps. So for example, this I'm now working just to make sure we are all on track. I'm going to work on this single float. So right, I'm going to debug this value in Unreal. So I'm going to select the float. I'm going to enable the debug. Then we can print it both on the log or on the screen. Let's take a look at what that looks like. So when I play, I will see here that it starts to print. What that really means is that it's giving me the value in the screen of Unreal, but that it's the only one that can be colored. We can also go to the output log, which is this one. And here we also will get the value. So if I clear it and I start, you will see that the messages are going through. Ideally, that's what you see, because otherwise it means something's wrong and it's not really working. That's per module debug options. For example, I can also debug the address at the begin play. This will take just a while. It will give me the address, and then I see if it's initialized, and it also tells me the address of the thing. More useful data that is generated by the plugin is usually prefixed by this. So when you are in the output log, if you want to go even deeper into the plugin, you can type OSCT or just type the name, so OSCToolset, and then dots, and this will filter all the logs that regard to the tool. So for example, if there is any errors, it will print it here in red. Otherwise, it will give you that the subsystem is initialized, the settings are loaded, etc., etc. It also gives us this information where what address are we using, what port are we using, and then what modules are being initialized, which in this case is quite a lot because this example has a lot of different modules. Then, of course, every time we open, it's gonna do the same. It works the same way when we reset the settings. So here, if I save and reinitialize, you will see this prints again. So it just makes sure that it's what's been sent. To get an overview in TouchDesigner of what modules exist in our Unreal Engine game, I created a module called Debug. So this is a module that you can grab, and every time we play, it will be populated with all the modules that are in our game. Again, I just iterated over this since the last version. It helps a lot to check the names of the modules, the classes, the actor owners, etc. Like what addresses are there. For example, the operator name that we are using, what is the formatted address. Here, I also can just view it like this, why not? We also get the module type, if they are packed, if they have receiver or sender. It's like a lot of different things. So here I also made this filter. So for example, if you just want to check what are the floats that are in your game, if you're working on this for a long time and then you're like, oh my God, I don't even know where they are anymore. This could be a good way to do it. So for example, we have like 3 modules that are floats. We have one that it's getting values, and 2 that are being sending. We have the dance floor, which is over there. This dance floor, I think it's sending if we are inside or not. And just know that this debug option is not going to send values. It just sends like the base data type for each module. And here we have like, let's see what else is in here. We have a send float and a get float. That's it. We are missing one actually, which is the pack, because the pack is not toggled on. So here, if I toggle the pack, we will see that we have one pack called noise float. So it's this one. These are just different options. If you just want to check the receivers, for example, well, we have only one receiver, which would be this one. And this is a nice way to visualize where everything is, which is super useful. At least it's been for me for the last weeks. Now, with all this talk, there's just one more thing to mention, which is the settings, and a bit like, why the hell does this work? And it's basically because we are using a local host. Local host, as you can see, is this one. It has a default port and a default receive address. In Unreal Engine, the way you can change that is through the project settings. So I got rid of the settings file, so you don't have to do that anymore. And it's under here in the plugins, OSCToolset. You can also type it, which is what I do usually. I type OSCT and you will get here the settings regarding the OSCT. You can see it's the same. So instead of using a local host, we use this address. This is also local host, but it's instead of the name in the string is the numbers. And then we have a port. That's how it works. I also added a menu, which is permanent, and it works to be used in packaged builds and also shipment builds. The reason I did that is that these project settings, once they are packaged, they're quite difficult to change and not so user-friendly. That's why I created, let's take a look, it's at the back. I created the settings menu. Let's see if I get there. There you go. There is a global shortcut, which is Ctrl-Shift-O, and it will open this window. Now, because I'm very windowed, it's not that big, so I'm gonna make it a bit bigger. I press Ctrl-Shift-O and you will see there's like this new widget here. This is available in any build that uses the plugin of the OSCToolset, and here we can change the settings directly, which is super useful, and you don't have to add any ini files or whatever. Let's take a look. For example, I can change the receive port to like say 9993, and I can then save and reinitialize. Now you will see that everything will stop because our client and server are no longer listening to the right port. What does that mean? Is that I'm receiving at the port 9093, but TouchDesigner is sending at 9999. So here I would basically add the 3 and it would work. It will take a little bit because messages have to be sent, but that's a bit how it works. If I would go back to 9999 or whatever address you are working, this is useful. If you have 2 different computers, you can now just change this by here. It's really nice. Just add the proper receive and save port, reinitialize, and this will restart the server and the client of OSCToolset. The lifespan of OSCToolset, to just go a bit more technical, probably like 90% of the people are already not here. So if you are here, you probably are more interested on it. It's basically using a game instance in Unreal Engine. Every time we open a new session, we can call it. So when we play a level, we initialize a game instance object, even if we don't see it. And it's basically deleted on stop. So this will be living as long as we are playing, right? So it's the main object that listens, and it's persistent across levels as well. So here in the maps and modes, you usually have a game instance class, and here you could have your own. If you are saving data or whatever, you would do it here. OSCToolset is using a subsystem. It means that it uses the same approach as a game instance, but you don't have to do anything. It already lives within the thing, and it will listen to these project settings that I just showed, and it will create the client and the server. For example, if you want to use the client and the server from the main OSC plugin from Unreal, which is what OSCToolset uses, here you can see in the plugins, when I type OSC, OSCToolset is dependent on the OSC plugin from Unreal. I'm using their client server creation, so it is a lot easier to code. Of course, it's not included. This plugin OSC, it's always included in the Epic game. So I'm just having how's it called? There's a name, a dependency. So it is dependent on that. So it will automatically enable it. But if you would like to use one of these clients and you don't want to set it up, we can call this game instance, right? Sorry for so much talk, but it's kind of difficult. So here you can type OSCT master, and the master will contain both the client and the server. If you want to send any type of messages or receive any type of messages with the same client and server, this is how you could do it. In this way, you don't have to initialize anything, and you always have this in memory, which is quite important. There's a lot of tutorials online that show how to make connections with the TouchDesigner and Unreal, but what they all get wrong is how to initialize these things, because they either do it in actors or they do it in like weird places. So in my opinion, this would be the most ideal way to work with OSC, is that you just create a client and a server on the start of the game and you clean it up at the end, right? What I mean by all this talk is that you could still use the OSC original server. For example, here you can say bind event, all these things, right? You could do the same thing. It would be a shortcut and you would not have to create your own clients, your own servers. And here you have further customization if you need. Most of it, I don't think you would, but it's just extra information if you are interested. This is how it creates the thing, and that's why it works, basically. Let's say that you want to package now your project in Unreal Engine. I have these examples and I want to make an executable out of it. If you're going to perform or use it in an exhibition or whatever you need the project for, you don't want to run it in the editor, so you want to package the whole project. To do that, you have to package it from here. You have to select a platform. As I mentioned previously, this plugin is only for Windows, at least the Unreal side of things. So you can only package for Windows, and you have to select what type of binary configuration you want. For example, development will show you the print logs in the screen, and shipping will not show that. And shipping, I think, also doesn't include the console. By the console, I mean this console. So for example, I'm going to play. This is the console. If you use a development build, I think you still have access to this. But yeah, these are just details in that regard. The issue or the thing you have to take into consideration is what type of project you created. When you make a new project, you are prompted with this window, right? The project browser. Here, if you select Blueprint or C++, if you want a successful package build, you will need to install the plugin in one or the other, or different locations, basically. If you use Blueprints, you will want to save the plugin in the engine folder, and I will show you now. And otherwise, it's fine to have it in the project folder. In this diagram, I tried to visualize exactly what went wrong. It took me a long time to figure out. That's why this took a bit longer than I expected as well. But mainly, when you create a blueprint-based project, if you install the plugin in the project/plugins folder, right? By doing that, you just create a folder in your project root folder called plugins, and you copy the plugin there. The thing is that when you package it, it doesn't work. It gives you this error of the plugin cannot be loaded. The reason is that this plugin is C++ fully, so it's a code-only plugin. And the packaging process doesn't consider it to be included into the package file. What you need to do instead is to copy it here. So you go into the Unreal Engine version you have saved in your project file. You're gonna save it in the engine/plugins. You make a folder called Marketplace if you don't have it yet, if you don't have anything installed from the Marketplace. And then you just paste it there, and it will work in the packaged. What was really difficult to debug is that even if you put it in the project plugins, which is the way I distribute examples at the moment because it's much more convenient. It works in the editor, but it will not work on the package. Then technically, if you're going to package the examples that I give, it will not work. But the reason is that you need to add the plugin then into the engine folder. Why? I'm not sure, but if someone knows, you can let me know, and you maybe save a bit of time of understanding this chaos. If instead you make a C++ based project, it doesn't matter where you put it, and it will work in the project plugins as well. It was a nightmare, so you can just let me know about it. Okay, bye, thanks.